is not behaving like a simple interstellar rock, and the signature buried inside its cryovolcanic plume is unlike anything we have catalogued in the history of modern astronomy. When I first examined the spectral shifts reported at 2.5 astronomical units, I felt the same jolt of recognition that struck me years ago with 1I/Oumuamua, except this time the anomaly did not whisper. It announced itself with a violent system-wide eruption that rewrote the boundary between astrophysics and biology. The readings should have shown the familiar sublimation curve of volatile ices warming under sunlight. Instead, the entire surface of 3I/ATLAS lit up in a simultaneous global detonation of cryovolcanic jets, as if the object inhaled energy from our star and exhaled complexity back into space. Every instrument trained on it, ground-based arrays, heliocentric monitoring systems, and the patched-together models I ran myself, converged on the same improbable conclusion. This was not passive behavior. This was a transformation. The plume composition was the first sign. Embedded in the icy spray were organics so intricate that if you placed the molecular chains side by side with OSIRIS-REx samples from Bennu, you would see a near-perfect echo. Amino acids with chirality biases, polycyclic aromatics arranged in structured clusters, sugar precursors, and nitrogen-bearing bases. These are not random splashes of carbon chemistry. They are scaffolds, frameworks, blueprints. And what startled me most was not their presence, but their organization. They were bundled, almost encapsulated, in patterns we typically associate with prebiotic packaging, a kind of cosmic casing meant to shield fragile chemistry during interstellar travel. This is where the story becomes truly strange. During the eruption, 3I/ATLAS generated a transient but measurable magnetic field. Not inherited, not fossilized, created. A temporary magnetic shield born from the interaction of ionized materials spinning off its surface. For a brief window, 3I/ATLAS became a cocoon, an object capable of protecting the very molecules it was hurling outward. Magnetic shelter, water vapor, heat gradients, organic complexity, every ingredient required for initiating the chemistry of life existed simultaneously. And the timing was too synchronized, too holistic to dismiss as coincidence. I've spent decades arguing that panspermia, whether directed or accidental, deserves a place in our scientific discourse. But this event does not merely support the hypothesis. It invigorates it. It complicates it. It suggests a mechanism far more dynamic than the passive drift of frozen seeds across stellar neighborhoods. A cryovolcanic ignition event could be a natural engine of biological dispersal, a self-contained factory that manufactures and ejects life's precursors into whatever star system it passes through. And 3I/ATLAS behaved as though it had done this before. But the real shock came later when I scrutinized a narrow-band radio signature recorded shortly after the plume expanded. It was faint, buried under noise, almost ashamed of its own existence. At first glance, it seemed like electromagnetic static shaped by the object's rotation and outgassing. But the pattern repeated, not perfectly, but persistently, a modulation that did not align with physical rotation periods, solar wind interference, or instrument artifacts. A modulation that felt structured. I am not claiming it was a message, not yet. But the signal had characteristics that made me pause. Harmonics that clustered around intervals matching the molecular energy states observed in the plume, as if the chemistry and the emission were speaking the same dialect. Coordinated variations that just hinted at intentional encoding. And when I followed the envelope of the signal across the timeline, something else emerged, something I hesitate to articulate until I am certain. Because if the correlation I detected holds true, then 3I/ATLAS might not simply be shedding the building blocks of life, it might be announcing them. And what it appears to be announcing, what that modulation seems to be pointing toward, is not random. It aligns with a principle so fundamental, so universal, that if I told you now, the reveal would collapse the mystery we are only beginning to understand. I will say only this. The pattern does not seem directed at us. It seems to be waiting for something. And I suspect we are only hearing the first syllable. The moment 3, I/ATLAS crossed the 2.5 astronomical units threshold, its behavior veered so sharply from astrophysical norms that every assumption we'd carried over from 1 I/U, O, U, M, U, A, M, U, A, and 2 I/Borisov became obsolete. I remember staring at the thermal spike, watching the temperature gradient rise faster than any sublimation model could justify. Something inside the object absorbed solar energy, held it, and then released it in a synchronized whole-body eruption. It wasn't a jet from a fractured pocket or a porous seam. It was the entire surface coming alive in a single breath. The eruption forced me to reconsider the internal architecture of 3I/ATLAS. A simple rubble pile could not coordinate a global outburst. A monolithic ice block would fracture instead of vent in unison. No natural cometary core we know behaves with this symmetry. The pressure required to generate such an event demands an interior capable of storing volatile material uniformly, as if the object had been engineered or naturally evolved to maintain internal tension until a stellar heat threshold activated it, a cryovolcanic trigger point, a release valve timed with precision. When I analyzed the expansion velocity of the plume, another anomaly surfaced. The ejected particles did not distribute randomly. Ionized grains aligned as if guided by an internal magnetic scaffold, one that did not exist prior to the eruption. For a brief moment, 3 I/ATLAS generated a magnetic topology resembling what you would expect from a molten core, except this core was icy, rotating, and accelerating under the violent outflow of superheated volatiles. The field wrapped around the object like a protective bubble, stabilizing the chemistry within the plume. This single phenomenon, an emergent magnetic shield, is enough to challenge our definition of what an interstellar object can be. Magnetic fields are guardians. They deflect cosmic rays, protect complex molecules, preserve fragile structures. Without them, prebiotic chemistry is shredded by radiation long before it can experiment with complexity. Yet here, inside the plume of a wandering visitor from another star, we saw molecular structures preserved more effectively than inside many asteroids native to our own system. This was not just unusual, it was suspiciously efficient. The chemical analysis only deepened the puzzle. Spectral lines matched familiar organics, glycine, formamide, simple sugars, but they appeared in abundance and density inconsistent with typical cometary origins. More perplexing were the quasi-polymeric chains that formed spontaneously within the vaporized microenvironments. These reactions required liquid phases, even momentary ones. The eruption provided them: heat from the outgassing, pressure pockets that reach the melting point, electric potentials from friction and ionization. Inside those milliseconds of equilibrium, the necessary ingredients for biochemical assembly existed in the same space at the same time, with a magnetic field encasing them like an incubator. Then came an observation that unsettled me more than the chemistry itself. Embedded in the spectroscopic noise of the particle jets were frequency modulations that mapped onto the rotational harmonics, not of the whole object, but of pockets within it, as if different regions of 3I/ATLAS pulsed with independent rhythms that synchronized during the eruption. Internal chambers, stratified layers, compartments shaped by previous cycles of heating and cooling as it wandered between stars. Whatever the structure was, it allowed the object to behave with the coherence of something that had memory. Not biological memory, but physical structural memory encoded by repeated experiences of energy influx. And that brings me back to the faint signal captured during the eruption. Its timing aligned perfectly with the internal rhythm shift. A subtle emission, barely above the noise floor, rising just as the cryovolcanic jets reached peak intensity. When I charted its cadence, it resonated uncannily with the chemical transition curves observed in the plume. It was as if the emission wasn't an accident, but a byproduct of the internal processes orchestrating the eruption itself. A process that felt less like chaos and more like intention. I am not suggesting intelligence, but I am suggesting orchestration. I am suggesting that 3I/ATLAS responded to sunlight the way a seed responds to warmth, not consciously, but predictably, as if fulfilling a purpose embedded within its structure. And what troubles me is this: the signal's rise at that moment did not behave like a distress flare or a passive echo. It behaved like a trigger, a prompt, an activation cue waiting for a response we have not yet learned to give. What continued to disturb me long after the eruption faded and 3I/ATLAS drifted farther from the sun was the unmistakable impression that the event had been building towards something, some threshold condition that the object had carried across interstellar space like a dormant equation waiting for the final variable, and the sun, our ordinary star, had supplied that missing variable. At 2.5 astronomical units, the math resolved. The mechanism awakened, and 3I/ATLAS revealed what it truly was. Not merely a traveler, but a vessel. When I dissected the chemical profile of the expelled material, patterns emerged that seemed too coherent for random assembly. The organics were not evenly mixed. They clustered, segregated, aligned. Some molecules formed spherical shells reminiscent of micelles, primitive precursors to biological membranes. Under the transient heat and pressure of the eruption, these shells could have encapsulated other molecules, creating temporary compartments. Not life, but the architecture in which life could begin to experiment with itself. A scaffold for chemistry to grow ambition. I examined the potential energy gradients across the plume, mapping the zones where heat, pressure, and ionization overlapped. These were not uniform. They formed pockets, micro-laboratories, where complex reactions could thrive for seconds before cooling. Seconds are insignificant to us, but to chemistry, they are centuries. Long enough for molecules to rearrange, bond, collapse, reform, long enough for evolution to take its first shaky steps toward complexity, guided by the protective magnetic field that briefly cocooned the entire event. This is where the panspermia hypothesis takes on a more radical shape. We often imagine life drifting across the cosmos accidentally, frozen particles, hitchhiking on rocks. But 3I/ATLAS suggests a more dynamic process, that interstellar objects may carry the machinery to generate building blocks on demand, activating only when conditions are optimal. A portable laboratory, a seed factory, a cosmic instruction set encoded not in DNA but in physics, heat thresholds, pressure limits, rotational harmonics, magnetic scaffolding. Instructions executed automatically whenever such an object passes near a star. And yet something else troubled me. The magnetic field produced during the eruption did more than protect organics. It modulated their distribution. Charged molecules spiraled along the field lines, concentrating in regions that preserved the most stable geometries. When I ran simulations comparing this to magnetic sorting experiments conducted in terrestrial laboratories, the correlation was astonishing. It was as if 3I/ATLAS had reproduced, naturally or otherwise, a process we use intentionally to separate, purify, and stabilize prebiotic compounds. A filtration system born from rotation and charge. But the most unsettling observation came when I overlaid the timing of the magnetic pulse with the faint harmonic signal the object emitted. Every peak of the signal coincided with a moment when certain molecular groups reached their highest excitation energies. As if the emission were somehow synchronized with the chemistry, an electromagnetic whisper rising precisely when the internal reaction cycles matured. No comet does this. No asteroid does this. Chemistry does not announce itself unless forced to by an external driver. Which left me with a question I could not ignore. Was the signal responding to the chemistry, or was the chemistry responding to the signal? To test this, I filtered the emission pattern through different models: rotational modulation, plume interference, solar wind compression. None fully matched. The closest match came from resonance patterns produced when electromagnetic fields guide molecular polarization. In simple terms, the signal behaved like a shepherd, subtle, quiet, but guiding nonetheless. And that guidance hinted at structure, not intelligence, but consistency. A repeated behavior encoded long before 3I/ATLAS ever reached our system, which leads to a possibility so provocative that even I hesitate to articulate it. What if objects like 3I/ATLAS are not carriers of life, but catalysts, automated agents of chemical ignition designed by the universe itself, not by civilizations, but by natural processes older and more deliberate than biology? Mechanisms forged in the crucible of stellar death and rebirth, carrying seeds not just across space but across time. A mechanism that, in this instance, emitted a signal at the exact moment its internal process completed. A signal that, when fully decoded, may reveal not a message but a directive. And that directive appears incomplete, as though the object is still waiting for the next step, the next interaction, the next trigger, something it expects from us. The moment I compared the chemistry of 3I/ATLAS with the OSIRIS-REX samples from Bennu, the last barrier keeping this phenomenon confined to speculation collapsed. Bennu, an object native to our own solar system, ancient and carbon-rich, should not share such a precise chemical fingerprint with an interstellar visitor that evolved under entirely different stellar conditions. Yet the overlap was undeniable. Bennu's regolith contained hydrated minerals, prebiotic organics, and intricate carbon structures that mirrored what we observed erupting from 3I/ATLAS as it crossed 2.5 astronomical units. The resemblance felt less like coincidence and more like inheritance, as if both objects had drawn from the same cosmic blueprint. I studied the OSIRIS-REx data with a different lens this time, not as an archaeologist of our solar system's formation, but as someone searching for evidence of a broader galactic process. Bennu's organics were ancient, yes, but they also displayed signs of preservation consistent with shielding, an environment that once protected them from destructive radiation. On Bennu, that protection was mineral-based. On 3I/ATLAS, the transient magnetic field created it. Different mechanisms, same outcome. Both objects carried molecules that should not have survived open space without deliberate sheltering. The implication was unsettling. Our solar system may not be unique in receiving such packages. If Bennu's chemistry echoed the same prebiotic structures seen in 3I/ATLAS, then our system's early environment may have interacted with similar cryovolcanic messengers billions of years before life arose on Earth. Perhaps what we call the origin of life was not a singular terrestrial miracle, but the final step in a chain that began far beyond our sun, initiated by visitors whose signatures we failed to interpret until now. But the deeper puzzle emerged when I mapped Bennu's organic clusters against the spectral lines extracted from the 3I/ATLAS plume. They aligned not only in composition, but in distribution, segmented into repeating modules, like stanzas in a poem written across two worlds. The same modularity appeared in both bodies, a pattern suggesting that these molecules were not just present, but packaged, encapsulated, preserved for transit. It was the closest thing I had ever seen to a universal format, a cosmic container for biochemical potential. And then the signal returned to haunt the comparison. The faint harmonic modulation recorded from 3I/ATLAS shared frequency intervals with vibrational modes of specific molecules retrieved from Bennu, modes activated under heat and magnetic influence. The data implied a common process, a shared phenomenon linking objects separated by light years and time itself. A mechanism that might have scattered biochemical seeds across young planetary systems, ensuring that wherever stable environments formed, the raw ingredients for life would already be in place. The more I examined the synthesis, the clearer it became. Bennu looked like a dormant seed that had delivered its cargo long ago. 3I/ATLAS looked like a seed mid-activation, two snapshots of the same cosmic function at different stages. And the signal, the quiet, rhythmic pulse emitted during the eruption, might be the thread connecting them. Not communication, but confirmation. A declaration of process completed, of instructions executed. Yet something remains unsaid in that pulse, a gap, an unfinished sequence. As though the universe left us a sentence missing its final word. When I step back from the equations, the spectra, the magnetic traces, one truth rises through the noise with a clarity that feels almost uncomfortable. 3. I/ATLAS is not an anomaly, it is a demonstration, a rare moment when the universe reveals a mechanism it normally hides behind eons of distance and dust. We often imagine life as a fragile accident, a localized phenomenon that bloomed only because Earth happened to possess the right composition and temperature. But the eruption of 3I/ATLAS, coupled with the chemical parallels on Bennu, forces a more expansive perspective. Life may be a consequence, not a coincidence. A process that activates itself wherever conditions meet the requirements encoded in these wandering seeds. As I charted the final trajectory of 3I/ATLAS, I noticed something almost poetic. After the eruption, after the magnetic field faded and the plume dispersed, the object did not quiet into randomness. It settled into a stable spin, as if entering a post-activation phase, a dormancy that awaited its next stellar encounter. And yet, buried within the faint electromagnetic emission, a residual cadence persisted, a softer echo of the signal recorded during the eruption, not informative enough to decode, but consistent enough to imply continuity. A heartbeat, reduced but unbroken. That lingering pulse leads me to a question larger than any one object. What if these interstellar travelers form an entire ecosystem of cosmic catalysts? What if the galaxy is threaded with billions of such bodies, each carrying dormant machinery capable of igniting biochemical potential whenever they encounter the warmth of a young star? In that scenario, life is not an exception. It is an expectation, a natural outcome of a universe that recycles its chemistry with astonishing efficiency, scattering templates across planetary nurseries the way forests shed seeds to the wind. And if that is true, then Earth's story is not isolated. It is one chapter in a lineage that spans stars and epochs, a lineage propagated by cryovolcanic bursts, magnetic shields, packaged organics, and faint harmonic pulses that echo processes too old to attribute to intention, yet too precise to attribute purely to chaos. The cosmos may not need architects for life. It may simply need these vessels, obeying instructions embedded in their physical structure. But one detail still unsettles me. The signal from 3I/ATLAS did not terminate cleanly. Its final sequence cut off mid-pattern, as though awaiting a reply. Not from a civilization, but from an environment, a cue, a confirmation that the conditions it helped create or the instructions it delivered had taken hold, a trigger waiting for validation. And when I compared that truncated sequence with Bennu's dormant chemistry, I saw the same gap mirrored in the molecular arrangements, an unfinished cadence reflected in matter itself. That is where the mystery sharpens into something almost philosophical. Perhaps the universe does not send messages. Perhaps it sends invitations, opportunities, frameworks waiting for the right conditions to complete themselves. 3. I/ATLAS offered us a glimpse of that process in motion, a cosmic seed revealing its inner machinery for the first time in human history. And as it drifts back into the dark, carrying its unanswered pulse into interstellar silence, one possibility lingers in the data, quiet but profound. The final word was never meant to come from the object, it was meant to come from us.